Okay, having a wee go at this one. 2015 C3, and it is question 8b. So first of all, I like to split it up. Cos is the same as sec squared. Bringing that 3 out of this integral, plus 5 ex dx, plus tan. I'm not going to leave it as a tan. I'm going to write that. Just what's going through my head at the minute is the trig differentials. So sine goes to cos, no good. Cos goes to minus sine. Tan goes to sec squared. Cot goes to minus cosec squared. Sec goes to sec tan. That's the one there that I'm thinking of, because 1 over cos is the same as sec, and I've got my tan. So I know that I can go backwards from it. So we'll just do that. Sec tan comes from sec. Derivative is a 1, so it's going to go back to your sec there. So it's sec x. Don't forget your c. Ex must have the derivative in front, which is a 1. Already have that, so it just goes back to ex. Do I have the derivative of the bottom on the top? No, because the derivative of this is minus 4, so I need a minus 4. So balance outside with the minus 4. So it's minus 3 over 4 log the bottom line. And this one, sec squared, if you look over at the wee list, comes from tan, but I must have the derivative in front. Derivative of this is a 4, so pop it in front, balance outside, so it's a quarter tan 4x. And that's that question done. Okay, next one we're going to look at from the same year, but it's a C4 paper, so we'll just get that up. And we're going to start off with question 2, and it's a substitution. So, do your du by dx, rearrange it so dx is du. So whenever I'm putting my du in, or it's just going to be a straight swap there. X is u add 1. So x is u add 1, then your minus 2, over. This bit here is your u. I may as well just change my integrals here at the same time. When x is 2, u is 2 minus 1, which is 1. So this is u equals 1, because that's x. And when x is 5, u is 5 take away 1, which is 4. So u equals 4. So what I have here is u minus 1 on the top, and I've got u to the half on the bottom. So just split that up, u over u to the half, du minus 1 over u to the half du. That's the power of 1. If you're dividing numbers, subtract the powers, so it's u to the half. This one comes up as a minus a half, and now finally I'm ready to integrate. So you add 1 and divide by it, which is the same as turning upside down. So you add 1 and you divide by it, same as turning it upside down. Your limits are 4 and 1. So subbing in 4. The square root of 4 is 2. 2 cubed is 8 times 2, 16 over 3, minus. The square root of 4 is 2. 2 times 2 is 4. And then subbing in 1. So it's 2/3 minus 2. And if you just plug that straight into your calculator, so it's 16 over 3 minus 4 minus 2/3, and that becomes plus 2. You get 8 over 3. Okay, another one from that paper is question 6, and you want the volume. Now if you remember the formula for volume is pi y squared dx. So your y squared from up here is a squared minus x squared. So it's pi a squared minus x squared dx. So you can integrate that quite easily. X reappears, add 1, divide by it, and your limits are a and a over 2. So subbing in a, we get a cubed minus a cubed over 3. So that gives me 2/3 a cubed for the first bracket. Take away, sub in a over 2 for here. So you have a squared times a over 2. So you have got a cubed over 2. Take away, sub in a over 2 in here. So you've got a cubed over 8, and then a wee 3 in the bottom. So that becomes a cubed over 24 for the second bracket. So just tidying that up, 2a cubed over 3 minus, that's 12 over 24, take away 1 over 24 is 11 over 24. And we're nearly finished here. So that times 8, that is 16. So 16 over 24, take away 11 over 24 is 5 over 24. So your answer is 5 pi a cubed over 24. For part 2, you're told that equals, see part 2 over here, that this equals 2880 pi. Pi's on each side, just cancel them off. Bring that across and multiply. Bring your 5 across and divide, and that leaves you a cubed. So 2880 times 24 divided by 5. And then you have a cubed to be 13824. So a is going to be the cube root of that. So in your calculator, the cube root of that answer gives you a to be 24. And we have one more to do out of this question, or this paper. Okay, so integration by parts. And if you can remember, whenever you're doing integration by parts, u is always the log. So dv by dx is the other one. Differentiate this. To differentiate the log, it's a derivative over the function, so that cancels the 2 over x. To integrate this, just add 1, divide by it. So using your formula, your integral becomes uv minus v du by dx dx. So it's u v. Now don't log the second bit, so it'd be a good idea to put it in front. X3 over 3 log x squared minus the integral of v x cubed over 3 du by dx is 2 over x dx. So minus. That leaves you 2x squared over 3 when you tidy that up. So x cubed over 3 log x squared. To integrate, you add 1 to the power and you divide by the new power. So it tidies up to x3 over 3 log x squared minus 2/9 x cubed at c. Now, part B, a little bit more awkward here. So it's not a bracket because the derivative of sine would be cos, so that is no use to me. Trying to think of how to get rid of this cube, so I'm not liking that cube. So I'm thinking if I split that up as sine x and then a 1, or a sine squared x, see if I can do anything there. I'm just going to play around with this sine squared x for a minute. Now, this might be a wrong path I'm going down. If it's wrong, I'll just start again. Make it look a bit better. So sine squared is 1 minus cos squared. So let's see what I can do with this. So it's 1 minus cos squared dx. Remember, this is the last question in the paper, so it is going to be quite tricky. What have I got here now? I've got cos squared x. I'm still thinking brackets, and this might work. Minus, so that's me multiplying the first, multiplying out the next. So it's this times cos. So it's cos 4x sine x dx. I can work with that. I'll show you what I'm thinking. I'm going to treat this as a bracket. The derivative, to integrate a bracket, you need the derivative in front. The derivative of cos is a sine. Sorry, cos goes to a minus sign. So I need to have a wee minus in here. Balance outside. Now I've got the derivative of the bracket in front. I can add 1 to the bracket and divide by it. I'm going to do something similar over here. So sine x. My bracket this time is cos x to the 4. Derivative of cos is a minus sign. So we need to put a minus in there and balance it outside, which turns into a plus outside. I've got the derivative of the bracket in front. So you add 1 to the power and you divide by it. And then you have limits to put into this. So pi over 4 and 0. So putting in your first limit, minus, I'm just going to use the calculator here, cos pi divided by 4 is root 2 over 2 cubed divided by 3 plus, and I'm going to put in here your cos pi over 4, which is root 2 over 2 to the power of 5, minus, putting in 0. Cos 0 is 1, so that's a third, and cos 0 works out to be 1, which makes that a fifth. So let's see now what we have here, just tidying this up. It's minus root 3 cubed is 2 root 2. 2 cubed is 8 times a 3 is 24 in the bottom. Plus root 2 to the power of 5 is 4. I'll just double check that. It's 4 root 2, I think. So it's, 4 root 2. 2 to the power of 5 is 32. And then you times it by 5, so you get 160 in the bottom, minus a fifth, take away a third, gives me minus 2 fifteenths. That cancels 2 over 40. So I'm just going to put this into the calculator. Root 2 divided by 40, take away, that's going to be root 2 over 12, root 2, so it's root 2 divided by 12, and then it is, I think I want it exact in there. I'm just going to put this all over 120, so times this by 10, so you have times this by 10 minus 10 root 2 times this one by 3, you have 3 root 2 plus, I want that up into 120, so I'm going to times it by 8, so it's 16 over 120. Tidying it up, I have got minus 7 root 2 plus 16 over 120.